All right, so welcome everybody. Thank you very much for connecting. So, in case you don't know us, we are the Informs Quality, Statistics, and Reliability section, and we promote interaction among scholars and practitioners in quality, statistics, and reliability. And we have a strong emphasis on research and real-world applications, with more than 1,000 members in across many countries and regions. So this is just a reminder, or in case you don't know, you can join the section. We like to organize many events, conferences on the many aspects of quality, statistics, and reliability. And there are two ways to do that, either through if you're an Informs member, you can just add QSR as part of your registration package, or you can also join the QSR section directly by just submitting a form. So all the details are in these QR codes that you can scan in order to be directed to the website. So today we are very pleased to have the third edition of the student engagement session with industry experts. So we have three people who have plenty of experience in working in industry. Specifically, we have Marco Antonio Guerra from Baker Hughes. We have Wenjun Zhu from Meta and Christian Bueno from Amazon. So before officially starting the session, I would like to just thank the organizing committee for all the effort that they have paid into organizing this nice session. We have Bill Fisher, Luis Segura, Hee-Yoon Kim, and myself, Alan Vasquez, who are the organizers. So at this moment, I'm just going to stop sharing. And we are going to start with the same order that we have in the flyer, meaning that we will start with Marco, then with Wenjun, and after that, Christian. So each of you have 15 minutes to introduce yourself and talk about your work. And then after that, we will have our interactive Q&A session. All right, Marco, so the floor is yours.
Oh, thank you, Alan. Good morning, everyone. Thank you for inviting me again. When you always contacted me a few weeks ago, I was really excited to be part of this session. I used to be part of the ASQ committee back in college, and so I'm really glad you guys are keeping this type of sessions open for the students. It's going to be extremely helpful for your careers, guys. Let me share my screen. Let me know when you guys can see my slides, please.
Yes, we can see them. Yeah.
Okay, good. So I'm working in an office that's not mine today. I came to work in California for a project I'm running. So I cannot see you right now. I'm working only for one screen. So if you don't mind, Alan, if you can do a quick time check while I'm working on this, I will appreciate.
All right, I'll check.
Good. Okay, thank you. Well, my name is Marco Antonio Guerra. I'm an engineering manager at Baker Hughes. I'm located in Claremore, Oklahoma right now. I'm originally from Ecuador. That's where I met Luis Segura years ago. He and I, we are colleagues. We both went through mechanical engineering school back in Ecuador. And I've been at my career since then, almost 20 years in the career right now. So today I'm going to talk about my past, mistakes, wins, and the lessons that quality taught me during all these years. It's going to be an interesting journey. And then when you guys invited me to this conversation today, I went through some of my old pictures, trying to go through what quality and reliability means to me. I always think quality and reliability, but they both work hand by hand together. And I was thinking about all good times, good memories, and failures and wins and everything that I learned through all these years in my career. So just want to at least share a hint with you guys to what I went through, and sharing something about myself, and hoping to connect with you in the future, and always open to have further communication, and always looking forward to meet new colleagues in the industry. I just put my email contact information here for you guys. So first of all, we're currently working Baker Hughes. Quality is a non-negotiable. That's extremely important for us in everything we do. When I go back to my career, it's completely true. This motto became part of my day-to-day activities. Every step that I made during all those years of working, no, quality became extremely important. And I will walk you through my career path so you can at least have a reflection of how a mechanical engineer from university in Ecuador went through different steps in the career to become an engineering manager now, right now at Baker Hughes. But quality, non-negotiable, extremely important. And what this means is basically, quality is not the sole owner of quality itself. You need to have everyone who's working with you around you being fully responsible for achieving proper quality on every step they're doing. So it's quality is something you actually need to live day on day by day basis, making sure you and your teams are not fully engaged, in order to deliver the right way. There is something that we have a campaign in our company right now, which is called "Quality is on Me," which it has been one of our main drivers during last, I would say, 3 4 years. And I'm gonna you're gonna see this several times in my conversation today, because it reflects the importance of quality. Quality, is part of every one of the colleagues you're gonna be working on daily basis. Um, I was mentioning I put some pictures of my career path here, and that's because now I went through my years back in the field when I started working on the oil rigs, and went through some of my teams that I had back in the time and the current team that I have. And when I go back to that journey, quality was always present, reliability was always present. The pictures that you see at the top, it was wearing the coverall, and my one of my first teams back in the Amazon in Coca, Ecuador, spending years there, working actually with the tools on hand, doing either assembling tools, um, doing installation on the field side. And then as the career progresses, that's in my 20s. I'm right now 42 years old, but back in my 20s when I started as a mechanical engineer, I became basically working hands-on. No, that's when you start switching or you start thinking about how your career will be progressed during, as you keep develop your journey as a professional, right? So from basically being mechanical mindset, thinking, oh, I want to work with no wrenches on hand, I want to do no things, or want to innovate in something new. Was basically my first years working on the field, working with colleagues on the shop, then building up the career. Start working with engaging customers. Some of the more like focusing on design itself, working on the designs that's going to be applied in the field. um, my current team is the one you see here on the right. It's just part of the team. Right now, I'm working with roughly 20 engineers, basically. This is the team that they just received an award last year in something we call internally in the company's innovation challenge. So we went through a challenge to design specific new tools, and my team won one of the awards. So I'm extremely proud of working and developing the new generations of engineers that are working with us. The pictures below represents a lot to me. I had the opportunity to go to Denmark last year to work with the University of Tulsa. I'm pursuing a master's in energy business right now. And that means also the need to continue the evolution of yourself, to continue learning, do not stop learning, to keep engaging. So I'm focusing not only on oil and gas, but right now at least switching my mindset to more type of energy, keeping energy technology as a focus. And the picture on the right, one of my good friends, Gordon. We went through many projects, so I thought it would be meaningful for me to have the picture here. My career path, guys. Well, as I mentioned, we started back in 2008, 2007 when I graduated from as a mechanical engineer. And as you can see here, I built up through different positions. I started my first years doing working towards welding and steel structures, kind of what I was very focused on. And then I decided to do a master's in manufacturing in the University of Southern Illinois University of Carbondale in Illinois. I was able to get a scholarship, so dedicating time to prepare yourself. I was able to learn English during my previous years. Got a scholarship. Was able to go to Illinois to get the masters, and went back to Ecuador and started working again back in the steel structure industry, still focusing on welding, where Six Sigma was one of the priorities. Standardization focus was a lower priority. When I did my master's here, I became a certified Six Sigma green belt and then a certified Six Sigma black belt, and that was extremely helpful for me to the career. That's when I kind of started getting my uh, lean towards quality and the importance of quality, the importance of reliability, and becoming a Six Sigma black belt was extremely helpful for the remaining years of my career until now. Um, then I built out my career towards being a reliability engineer, being a shop manager, being a country manager, regional manager for Baker Hughes, and right now being an engineering manager in the product center for Baker Hughes. So in all those years of work here, I would say quality, reliability, Six Sigma have always been present, have always been extremely helpful for me. Now, in order to keep the mindset, not only for the importance of what those fields are bringing to our products, to our customers, to our operation, but also the importance that they are bringing on our continuous improvement philosophy, not only as a company that you're working for, but also as an individual, as a professional. So I would say, 20 years of career basically, where quality became part of my day-to-day activities. And again, it's something that you live on daily basis and what you're trying to execute. As I was mentioning before, quality is on me. It's one of our main mottos right now. And we are probably displaying this in the company everywhere you walk. And you go to a shop, you go to operation, you see people talking about the importance of quality. And as it says here, you just take the right mindset and work approach to make it happen, to make the right way. Uh, Things that we usually do on a daily basis, where you involve the importance of keeping your product with high quality, high performance, very reliable. You go through different analysis of how to manage a process, the importance of having the process interaction, doing evaluation, not only for Six Sigma but also lean manufacturing, getting deeper and deeper into understand the proper workflow, the proper process, having evaluation for risk and opportunities. For example, when you're going to run a new contract, when you're going to run a new initiative, a new project, evaluating deeply. Again, not only focusing on quality but also HSE business perspective. uh, there is the quality, reliability. I always say, I would say that's the cherry on the cake for making things the right way, the proper way. But you also need to understand you have a running a business, so having proper evaluation while keeping all your cards on the table is extremely important. Um, Here's another example. Also, when we do new product development, we go from the concept design, through different steps of evaluation, detailed evaluation, detailed designs, validation, commercialization. Uh, Quality is always going to be present in every single one of those steps. And I just wanted to show you a list of how my day-to-day looks in um, applications itself. Um, right now, I'm currently basically in charge in Baker Hughes. I'm in charge of a global tooling group, which this group, what it does is basically we are the ones fabricating test equipment for our operations worldwide. So we run roughly around 40 different service centers, which is roughly 500 people. And in those 40 different service centers, we have specific machinery that's custom designed by my team. Basically, my team is the ones who are making sure they are fully compliant. They are up to API standards. And my team, it's a cool work it's a cool job for them, for the engineers. The engineers in my group, they basically are traveling around the globe. So, for example, this morning I talked to the people in Indonesia, people in China, people in Colombia. These are our engineers deployed to those locations where they are working, usually 1-2 weeks, making sure all the equipment, the specialized tooling that we have, specialized machinery is up to our standards. It's fully operational. They do a specific calibration on site. And sometimes we're working on commissioning like new locations, installing new machinery, new shops. And right now I'm in California with my team here, a couple engineers, where they commission. So we're relocating this operation to somewhere else. Another part of the group, right, they have right now under my control, it's they are focused on procedures standardization, procedures development. So we have a specific amount of people working on daily basis just to maintain procedures and making sure everything is up to standards for our execution. Very important for Baker Hughes right now. We call the 5 fundamentals for the quality. It's we're customer focused, making sure we're fully compliant, making sure we manage the risk properly. Always focus on a flawless execution, and of course, the improvement, as I mentioned before, continuous improvement is key. Continuous improvement is extremely important for making sure you do not get stopped or where you feel right now. It's always something else to do. Here is my gift to you guys. what's important, something important in your career to always think about, giving or receiving feedback. During all these years, I was referring at the beginning my wins, my mistakes, and I would say this is something very valuable. I would like to share with you the importance of giving feedback to your colleagues, to your peers. The importance of receiving feedback also will help you a lot to ensure you are um, no shifting. If you're shifting, no, you go back on track. You get to the right way. So feedback accelerates the growth for sure. Giving feedback builds trust and leadership to your colleagues, to your team members. Receiving feedback, it requires humility. It's not always easy to receive feedback, but it's very extremely important. It helps you to become a better professional, a better person always. And for sure, feedback drives quality and results. And no, it's feedback as you as a professional or feedback as a process or as a team. It's extremely important to make a much better environment for your operation. Um, this is my last slide here, guys. Something cool that I would like to share, focus on quality in our operation right now. Uh, we have the stop word for quality. So every single employee, if you have any um, action that you see in one of your steps that you see it's not working right. No, every employee from technician level, field service personnel, managers, supervisors, every single person in the company, they can raise their card and stop work for quality. Something's not wrong. It's not well here. Something's wrong. We will stop. We will communicate. We will evaluate. We document, and then we will move forward on taking the right actions. No, it's having an escape extremely painful. We want to ensure the customers are receiving the right product, and at the end of the day, like in everything you do in their life, uh, no good quality means good product, means good brand, means good name, and your name is always behind that brand. Also, it's behind the name of the company you're working for, or is reflecting the name of your team or your career for sure. So quality, no, good quality reflects, no, basically in my thinking, good quality always reflect proper commitment and of course a proper professional that's working to sustain that operation or that career. And that's with that. That's how I'm finishing my presentation today, Alan. Thank you very much. I really appreciate the time you guys are giving me for sharing with the students here today.
Great. Thanks, Marco. So we are right on time. So let's move on to Wenjun. Yeah, go
Yeah,
ahead.
so thank you for the invitation and thank you for organizing this wonderful panel. So I'm Wenjun and I'm now a research scientist working at Meta. And here is yeah, I want to introduce a bit about myself, about my education background and professional experience. So I graduated from University of Wisconsin-Madison. I get both my master degree and PhD degree in industrial engineering and with a minor in computer sciences. And during my PhD study, I have a research intern experience at Central Children's Research Hospital, where I work on improving the R package for screening too. Then after graduation, I work at ITIA. And at the time I joined the company, the startup company is called Genius Healthcare. And yeah, at there we develop digital twin models using causal modeling to discover the therapeutic discover drivers in Alzheimer's disease and ALS. And also, yeah, as nowadays the foundation model is quite popular, so we also explore single cell foundation models and their integration with causal AI for oncology applications like head and cancer or kind of cancers. And yeah, now I work as a research scientist or say machine learning engineer, work on late stage recommendation systems as Meta. While I cannot share too many details about my ongoing work here at Meta due to confidentiality, I'm happy to share a lot about my previous research at IDEA, because I still remain in close contact with my former colleagues, and yeah, still continue to follow the science closely. And yeah, for me, I continue to hold a strong favor for the AI-driven technologies to improve healthcare, particularly in elder patient care like neurodegenerative disease like Alzheimer's disease and ALS, because they are like urgent national health priorities and they are affecting millions of Americans and they are cost the US healthcare system hundreds of billions annually. So yeah, but yeah, the key takeaway here is that whether you study industrial engineering like me, or say operations research, or mechanical engineering, or double E, even if you are not deeply familiar with specific domain, as long as you have the like core idea on the methodology or technology like machine learning, AI, you can apply the method, the tech to any field that you are passionate about. And you can work for like a tech company or a traditional manufacturing industry, or like me, before a healthcare company. So what we learn at school or during our research experience is like a tool set or toolkit. And this tool can be applied to any field that we have favor for or that needs our skills. Yeah. So yeah, on this page, I wanna introduce a bit experience about my work experience at ITA, the healthcare startup, and also wanna address a common concern that like PhD or master student might have. Does moving to industry mean you have to leave research behind? So the answer here is no, absolutely no. So in fact, we can still continue to write abstracts, publishing papers, and still present at conferences. So here I put two abstracts that we presented at the CTAD conference. So yeah, for me, I still attend and present at these kind of scientific conferences. And yeah, as many of the students may do not know, many companies like ITEA and like Meta here, they generously reimburse all these kind of scientific activities like conference travel, registration, or even publication fees if you still have interest to publish papers. And yeah, on top of that, ITEA and Meta, like many tech companies, also provide something like a study funding. So there's money set aside for you to take courses or learn new skills and keep growing. So you can always keep learning and stay scientifically active. But yeah, so it goes beyond just funding, like the study funding. We actually can still actively collaborate with like research professionals, like university professors as our advisors. So let me give you a concrete example here. Here I paste a paper that is published by my colleague with a professor called Ole Isaacson. So he's a professor of neurology and neuroscience at Harvard Medical School. Um, so yeah, at that time he was our advisor on our neurodegenerative disease. And the best part is that our team members, we do have bi-weekly discussion with him on this project. And it's not like once a semester or not once a year. It's like we have bi-weekly discussion with him. And yes, so that means we are not just funding academic research from a distance. We are actively engaged, like exchange ideas, getting feedbacks, and stay connected to the frontier of academic research. So whether it's like publishing or presenting, taking classes, or collaborating with like here Harvard professors, industry does not mean that it is the end of your research life. And also, if anything, companies now also recognize that staying connected to academia makes us better engineers and scientists, and that's why they fund it accordingly. So then you may ask, though we can still do research in industry, what changes compared with when we do research in academia when we are a PhD student? So here I want to walk you through a few key differences between academia and industry based on my own journey from PhD to ICA and Meta. So first is a pace and goal. So in my PhD, I spent my first 2 years just analyzing the transient state, the dynamic state of a Markov chain. And my advisor, he gave me the time to explore deeply. But in industry, we move really fast. As at Meta, move fast is literally our top culture value. And like for idea, like for even for multi-year projects, you need to like have convincing deliverables at every stage because the contracts have deadlines for each stage. And in industry, the goal can also shift when we are doing research on it's mainly like discover something novel or like novel method or we apply it to a novel field. But in industries like generate profit, save time, or deliver customer values. And also in industry, although we still attend conference and do presentations, our audience changes. As a PhD student, you present to research peers who care about novelty of method or mention the use case. In industry, your audience is potential clients and stakeholders. So they don't ask if this method is novel. Indeed they ask, does this method solve our problem and can it save my money? And also the risk tolerance can also differ. Like academia can even celebrate negative results as publishable as long as the method is novel. But in industry, the negative results of failure means we can lost contracts or waste ROI. Yeah. And third is a collaboration and learning. So in PhD, you work mainly with your advisor or your lab group or your research collaborators. In industry, you're embedded with a cross-functional team like engineering or product or sales or even legal team. And you collaborate with all these cross-functional teams all at once. And yeah, we have study funding and can take classes, but it always needs to be tied to business relevance. So you don't learn something just because it's interesting. You learn it because it helps with the like product or say production. So yeah, the key takeaway here is that in industry, we absolutely still do research, but we do it with urgency, discipline, and a clear customer in our mind. And that is the real shift. And yeah, as I graduated in 2022, and now I have worked for nearly 4 years, I'm still, yeah, say new from study research to industry. So I still have some like job interview preparation tips for this kind of industry research roles. So I think what comes first is that you need to know your most proud research project inside out. We should expect like deep and wide questions to be asked during job interviews, not just what you did, but why and what if. We should prepare our like to present one of our research like a mock conference presentation like before my first informs, my PhD advisor made me like have a good preparation and anticipate every possible audience questions. And it is the same to apply to job interviews. And we should be ready to discuss, do we have alternative approaches, and what's the failure points, and what's the trade-off, and also possible extensions. And yeah, if you're interested in industry research roles, you also need to brush up on machine learning and also statistics fundamentals. Yeah, like create a checklist of the core knowledge. So interviewers will test both depth and breadth of your knowledge. Some example topics that I had during my job interviews are like the bias and variance trade-off, or overfitting, underfitting, regularization, hypothesis testing, p-value, confidence interval, this kind of thing, and also like the basic knowledge about machine learning, like gradient, descent, variance, convergence. And also, if it's relevant to your role, they may also ask about causal inference basics. So yeah, you should prepare this kind of knowledge checklist as if you are taking an exam. And yes, so if you are interested to be a software engineer or machine learning engineer, you need to also sharpen your coding skills. And lead code nowadays still remain a solid foundation for coding practice. And yeah, if you are I believe most of the schools, they have like a sign up event, so you can purchase annual legal membership with a huge discount. And I now still hold that legal membership discount. And yeah, that is a trick. And the new trend nowadays for the coding interview is that the AI assisted coding interviews. And now at Meta, we do have this kind of interviews. And you may be asked to use, or the interviewers, and they simulate like ChatGPT like tools to ask you to do the coding. And you should practice explaining your reasoning while using the AI assistance. And you also need to know when you can trust the AI and when you should debug manually. Yes. So yes. So the last one is about the behavior questions. In most of interviews, we still have a round called BQ, behavior question. So you should yeah prepare your stories with a STAR, the STAR structure, where the STAR they stand for situation, task, action, and results, which are the context of your story and your specific responsibility and what you did and what is the outcome and what you learned. Um, Yes, so we should, if you are preparing for an interview, you should have like at least 3 to 5 versatile stories, covering topics like whether you have conflict during your research or work, or if you have any failure, but what you learned from the failure, and also leadership experience and your collaboration experience. So the interviewers can test both your tech skills and your personality from this kind of interview round. Yep, that is what I have.
Thank you very much, Wenjun. So, all right. So to keep us on track, so let's go with Christian. So, Christian, you can now tell us about yourself.
Sure. Hello, everyone. Thank you for having me here. I'm going to start sharing my screen. Please let me know when you can see it. Can you guys see my screen?
Yeah, we can see it.
Okay, perfect. So, thank you everyone for having me. My name is Christian Bueno, and I'm gonna talk about my life at Amazon. Um, so basically, let's start a little bit about myself. I was born and raised in a beautiful city called Quito. It's the capital of Ecuador, located right where the equator line divides the northern and southern hemisphere. I'm a mechatronic engineer, graduated from the University of Armed Forces, where I had the opportunity to meet many excellent teachers who later became mentors for life. Actually, you had one of the people that put all this together, which is PhD Luis Segura, who, for as a fun fact, I met him when he was an engineer, and I still call him engineer, even though he's a PhD now. So that's how we treat each other. After I graduated, I moved to the US. I joined the University of Maryland to become a master in robotics because that was my passion, and I was trying to pursue my passion in technology. I joined Amazon in 2019 as part of the RME team as a control system technician, where I learned about the Amazon culture, the leadership principles, and that was key and fundamental for my journey inside Amazon. Another fun fact, actually, inside Amazon, we don't do presentations at all. Jeff Bezos doesn't like presentations, and that was something that was implemented since the beginning. We typically do a white paper or a six-pager every time that we have to do meetings, and we read it during the meetings, and then we discuss. Later in 2022, I joined Global Engineering Services as part of the SEC team, where I currently work. And I think it's enough for me. Let's start with something interesting now. Um, so Amazon is a very data-oriented and data-driven company that makes decisions only when data backs it up. In business, speed matters. So we tend to always use the philosophy of a two-way door to execute, but we always back that up with data. In Amazon, data is treated as a strategy asset for everybody. And we are also driven by some key leadership principles that are some tenets that are like deep dive, write a lot, which in reality require a lot of validation. Um, Inside Amazon, the data is very important. That way that we actually have some KPIs that define our successful for operations and MHE performance. Kind of going back to what is the manufacturing and how we are actually capturing and measuring all the data to define our metrics and goals. Everybody in Amazon has data access as much as they can, of course. There are things that are confidence, but data and democratized data access actually enable all the employees to be able to make rapid decisions. And as I said before, speed matters. We spend a lot of time and effort on real-time analytics and platforms, and everybody has the opportunity to create data and to read their data the way that they need it. And now with the help with AI, everybody can um, analyze the data in a different ways and patterns. So we provide the data as a raw, and AI kind of does the analysis depending on what everybody is looking at or what is the need of each person. That there are some pros and cons with that, but yeah, that's not something that we're going to touch right now. To give a little bit of an understanding of what I do as a control system engineer, my role typically monitors some performance of a machine. What I'm showing right now is basically a very generalized machine, and how is it working is a sorter that tends to divert packages to specific lines depending on what the locations. Imagine this as a package that is supposed to go to you, or different states, and each one of those lines are going to be different states. So the key performance that we analyze in these is, of course, the successful diverts, which is the most the key important goal that we want that number to be as close as possible as 100%. And then we spend a lot of time defining each one of the defects that we have. In here, we have operational defects, load balancing defects, MEG defects. So operational defects is simply as imagine that you have these lines are full and we don't have enough people to process all of these packages, then they become an operational defects. We are now managing a the associates of the people as the way they should in an efficient way. Then we got low balancing defects, meaning that this lane is capable, for example, the first lane is capable to actually handle 20 packages per minute, but we're actually sending it 40. Therefore, those extra 20 are going to have to go to Jackpot or to a different place where they actually are going to need to be reprocessed. So that's a kind of loading defect. And then we have MHE defect, which I have also pointed here at the bottom. We subdivide them in different categories where we are having lane full, nominal defect, fail to divert, throughput limit, and a defect. And all of these is how we are actually later subclassifying each one of these defects so that we are able to apply techniques to minimize this. Granted, I just show you a data of an average site. I cannot tell you exactly what site it is or the name of this site, but I can tell you that it was a 12 hours performance, which you can have an idea how many boxes we actually processed during this hour. It's not the biggest, but it's not the smallest sites. And this is just to give you an idea of how one of the small machines inside Amazon looks like. So to continue with this, as part of my current role, one of the things that we do right now is we actually created a PLC logic that track accurately the packaging merging in a 2-to-1 merge, where packages are merging from two sides going into an exit photo eye. The key interesting about part of this application is that we were able to track so accurately that later on, applying some statistics and very basic statistics, we were able to determine that the majority of the package distribution of the package flow follow this Gaussian distribution, right? So we were able to determine the normal package flow and with the medium. And if we calculated a distance or I would say a 3 medium tolerance, we were able to anticipate actually mechanical defects. So if we know that a package usually takes from one lane to go to the exit point and it follows into this package distribution, and for some reason we started to see packages that are following outside these normal graph of distribution, we're able to detect there is definitely something wrong mechanically. It could be a belt, it could be a motor that is starting to fail. And this type of data was actually later given to RME, which is their reliability maintenance team. So they are able to anticipate failures. So we don't have to wait anymore until a belt breaks or a motor fails completely. We start getting these signals ahead of time so they can anticipate, go check, find what is wrong, and actually go from proactive from a reactive maintenance to a proactive maintenance, we'd actually reduce about 70% of the time that it takes to react or fix most of the issues that we're seeing, and basically a 30% of cost savings across the sites where we apply this logic. So this is just a few examples where like we're combining high level logic or PLC combining with a very, very simple statistic methodology where we are able to anticipate one of the majority of failures that we have in industry that can affect operations drastically. Another example of what we do that actually require a lot of data is that from 2021 to 2022, Amazon has launched many sites. But in the majority of these cases, we always trusted in the vendor to apply lessons learned, meaning all the things that we have discovered from one side to the other needed to be carried over by the vendor. But noticing that the majority of the vendors were not actually having a good way to track all this data or a good methodology, we were noticing that in between these launches, we were having so many severities events. What is a SEV event for the people that don't know away from Amazon is basically an incident that drastically affected the performance of a machine, which highly impacts operation and distribution center. So this SEVs event, the majority could be prevented because we already created a site that it was very similar or to a high percentage of similarity. So why were these things not getting track and pass from one place to another? And that was the question that it kept affecting, and we keep asking ourselves. So what we did in this case as a solution, my team and I created a daily comparison for all the controls parameters that go across the network. So we're talking about reading 5,000 plus tags in an hour or more in comparison across like 20, 25 sites to determine which one is the best performance, and at the same time knowing which are the same parameters that are working for the majority of the sites, identifying any outlier and capable of understanding like if this outlier is unique, it might be an indication of an early mechanical failure. So all these detections are actually made in a very real time or as close as real time as possible. And data like this allow us to reduce from, for example, in 2024, where we started one side with 31 SEV events to the next iteration of this site to start with only 8 SEV events, which were truly mechanical failures, which was a defect from manufacturing. So a 75% reduction in control-related events from 21 to 22, which is great, and it was very, very valuable for operations. And then allowing a 29% reduction on PLC changes across the first 60 days. So those are the key things that actually help us reduce cost. And allow us to our team to get a very clear and understand improvement on what we're doing and how we're actually affecting and for them improving the metrics in a very good way. Additionally, there's one more example where we actually identify an issue in a sorter with the sorter was actually losing one of the packages. Long story short, the idea was for us to review thousands of more hours of footage to see where the package was actually being lost. But instead of that, we were able to analyze PLC logs and get machine learning and computer vision algorithms to actually detect these anomalies. So we were able to reduce this time from like hours or weeks of labor to like about minutes and detect the problem ahead of time, which my team later on was able to define a root cause of what was happening and implement a solution with a software patch that then later impacted the network. And we're talking about 45 plus sites, which also we gave that solution to the vendor, which it probably affected other companies that the vendor actually works on. And that's it for me.
All right. Thank you very much, Christian. So now it's time to open the floor for questions. And one of the features of this session is that we want it to be as interactive as possible. So, so having said that, are there any questions? And if you have, just unmute yourself and ask the question directly to one of the panelists. So while we wait for people to come up and formulate their questions, I would like to ask a question to Marco. So Marco, in your position, what is the role of AI? So is it used? Is it something that is interesting? So what are your perspective on the usage in your work?
Well, thank you, Alan. Yeah, people are shy today. We will get more questions for sure. No, definitely AI is extremely important right now. As Christian was mentioning, the value of data right now becomes an extremely helpful or extremely valuable asset for every one of the companies. And if you're, I would say right now we are living this revolution of whoever is able to control data, becomes more efficient on the way you apply your business daily basis. Right now, for example, in AI, we're using a lot on data analysis, machine learning processes also. Like everyone's mentioning about this test equipment that my team is designing, but no, with the machinery and execution, we collect a lot of data, the pump head, the pump flow, no different type of pumps, and no, we use data analysis through AI to understand what the outcome is and start making decisions. The value of data is to use the data for decision making later on, to start analyzing what else you can do or what else you shouldn't be doing right now. I personally use also for we're trying to perform analysis like I would say it's a great assistant right now when you are doing extensive documents, like for example you have to to evaluate a contract or you have to evaluate a specific project, then you have extensive information short period of time. It's helping you to at least to have an initial very quick analysis to get involved. Of course, you have to you do the rest of the homework, but at least for initial discussion, it gives you up to speed to what you're trying to use. Data management is extremely helpful for sure. Great question. Thank you, Alan.
All right, thanks. So any questions from the audience?
Hi, everyone. I would like to ask one. Well, thank you all for your talks. It was very interesting. And I would like to ask a question to Wenjun. And the question is, it was easy for you to change from an academic environment to the industry? It was easy or difficult?
I think I didn't feel the gap that much as mentioned, because yeah, when I study as a PhD, it's more like we try to design a novel method, or it's more like the methodology. But for industry, we also want to like design some new methodology, but it has a like specific use case because we now have contracts and we need to finish a project, and we do have the timeline. And I think it's somehow it's easier than do research, because like the yeah, from my previous work at IDEA, we first wanna like improve our model, wanted to improve our that digital twin to figure out a more novel gene or biomarker to be targeted for Alzheimer's disease. But then it is very hard, but we have a strict timeline in industry. So we just turn out to introduce a new method, like we do an embedded two layer modeling method, but it's not like introducing something really new. It's like a trick, but in that way we can also it's not like find a gene or biomarker that is new. It's like we try to solve the problem from another way. Like our goal is to save money, whether it's to discover a biomarker that is cheaper to be targeted or to be detected. It's like in that way we can still save some money when recruit the volunteers for the experiment. So I think in industry it's like the the requirement for you to do research is not as that high standard as you are doing research as a PhD student. You indeed need to design something new, something novel to publish a paper, or you can get rejected. But in industry, it's like you can always find something new from like the business point of view, or yeah, but you need to move fast, and you can always find a way out. Yes.
Okay, thank you. So you say that it's kind of easy to make this change from a PhD student to go to
Yes.
it's easy.
As long as you have the skill set, like for me, I do not have a background in biomedical. So when I
Mhm.
joined ITEA, or as now I work at Meta, I do not have a background for like recommendation assistance,
Okay.
but we do learn how to develop like machine learning models, or how to use AI as an agent to help us to do research or work on a project. As long as we have those knowledge and skill, we can use it in our And we are not, that's what I said is easier. We are not like developing a new method. We are not developing a new like AI agent. It's like we are utilizing them as a tool. Yeah.
Okay, thank you.
Yeah, thank you
All
for the
right,
question.
so we have a question in the chat that says, earlier in the meeting, failure was mentioned. I was curious, what was one instance of failure in your fields and how did you overcome it? So Christian, would you like to answer that question?
Yeah, of course. Well, I think the way that you define failure, it actually comes from like what is the philosophy of your company. I think at Amazon we define failure as an opportunity for improvement. So basically, I'm gonna tell you a story where actually we designed a machine that it was supposed to process, let's assume 70 packages a minute, right? Once it was built and it was put in place, the machine was simply not capable of doing more than 50. Immediately, Amazon, and in this case, my team was able to identify like three things, action items to do from here. Like, first of all, it was a team designed to a specific improve and analyze what was missing from a standpoint to fix this gap and analyze how much can we actually improve to get as close as possible from this. Now, once we had a team dedicated on that, there was another team that actually was actively working in a solution to correct this issue from a network perspective. So the other machines that they were related or already in the process of being built uh, had a solution already in place. And the third team in this case was dedicated to identify this issue from the root cause and fix it from a design standpoint. Why is this? Because just to give you an idea, machine it's been planned 2 years in advance. That means that once you have it already in place as it's built, it means that you already have 2 years of more of these machines. So any failure, any issues that you have to correct it right away. If not, you will have 2 years of the same issue. So that's how we divide and conquer in a sense that all these failures are simply just opportunities of improvement. And of course, that sometimes takes a little bit of cost from the design standpoint. But at the same time, we have to understand that any of the actions that we take, as long as they are in a good direction and they actually improve, is a win for us. And then Amazon has the luxury, I will say, to be able to allocate as many resources as they needed to fix any of these issues ahead of time.
Thanks. So we have just 1 minute for one last quick question.
Hello everyone. Maybe I have a question. First of all, thank you very much for the great presentations that we saw here. I'm gonna put myself in the on foot of the students. So I would like to know from you, any of you, what do you think the kind of tools the students have to learn in order to keep up with this fast changing world where technology is actually developed a lot, especially with this AI boost? What do you think from the different roles you are playing now are the important things to learn as for now?
So I think we can go with a, let's say, concise answer from each of you. So we can start with Marco.
It's great. Yeah. Thank you.
Thank you, Luis. Excellent question. Great to see you today. Definitely networking, human relationships. That's truly valuable right now. With the technology, I feel like the human connection is kind of getting lost. I mean, we have data, we have a lot of information on hand, but that touch of the human interaction, it's extremely valuable to keep developing yourself.
Great. Thank you.
So Wenjun.
Yeah, as Marco said, I think networking is very important because as mentioned, these days as soon as we have the tool set, we can apply to any kind of job we are interested in. But then you would compete with lots of people for one job. So if you like are brave to like reach out to someone you may know on LinkedIn or through networking and conferences, like the chance for you to get an interview through a referral, it's much more higher than you apply it directly. And also you still like should have a solid understanding of your own skill, like with the assistance of AI in work these days, you still need to input your skill sets and the AI or say the agent to like transform into a skill that you can use on your work. So your experience, your knowledge in your domain is still very important. Yeah. And yeah, coding, if you're interested in this kind of jobs, it's very important.
What about you, Christian?
So I will say, I don't think that we should try to impose anybody to learn a tool or a specific program. I think that, as my peers has just mentioned, it's basically the skill set. You have to learn how to be a good person, build your human resources around, like make sure that you communicate well with everybody and treat everybody respectfully. And at the same time, keep developing other fundamental aspects of your skills. Like, for example, you can learn how to code in the philosophy of coding, but you don't need to know Python or C++. It's the same. You could learn. You can learn somebody that knows how to code could learn PLC. It's the same thing. So the tools could be variable and you can be learning the tools depending on what your jobs needs. So what I'm trying to say with this case is like keep being curious. I think that one of the fundamental skills is for you is be curious of what you have around, question things, be curious of what is happening and why is it happening. As long as you keep that as driven you as an engineer, I think that the rest of all the tools are going to become very easy to learn, and then you're going to be able to mold yourself depending on what you need. So don't don't uh don't partner with a single place or a single software. Just learn the fundamental methodology behind it. I think that's way more important.
All right. So thank you, and thanks again to the panelists for taking the time to be here. Thank you very much, everyone. So I'm going to stop the recording